In section 2.7, number 5, there's a question similar to the following. Use the definition of a limit to prove that the limit as x approaches 4 of 1 over x is 1/4. So one thing we want to remember, in order to prove a limit, we want to show that the absolute value of the function minus the limit is less than epsilon, which is given whenever the absolute value of x minus 4 is less than delta. So we're going to start with a couple of things. As, what we know about this inequality is that as our number gets closer to 4, our delta is going to be small. So we are going to assume, let me put it in a different color here, we're going to assume that x minus 4 will be less than 1 at some point. And we're going to come back to that in just a moment. So we're going to start with our conclusion and say, let epsilon greater than 0 be given. This is our given epsilon, and we want to find the delta that relates to that epsilon. So we're going to start with this expression, and I'm going to get a common denominator of 4x. So I'm going to have the absolute value of 4 minus x over 4x is less than epsilon. I then want to take the absolute value of both the top and the bottom. So that's going to lead me to the absolute value of 4 minus x. And I'm going to write this one as the absolute value of 4 and the absolute value of x, because we know we can take the absolute value of 4, it's positive, so we'll be able to pull that out. I can also take the fact that if I factor out a -1 here on the top, we would get x minus 4, which looks a little bit more like what we were trying to show, and say that is less than epsilon. So what we're going to do here is we're going to take the absolute value of the -1 and the absolute value of 4 and drop those absolute value symbols. So we now have the absolute value of x minus 4 over 4x is less than epsilon. Oops, absolute value of x here. Okay, so now let's go back to our assumption up here and say, let's solve this inequality. So we're going to say x minus 4 is less than 1, greater than -1. I'm going to add 4 to each side, so we're going to get 3 is less than x is less than 5. And then we will take the reciprocal of each of these, and that is going to change the direction of our inequality. 1/3 is greater than the absolute value of x. Oops, let me not take it in absolute value, so hold on. 1 over x is less than 1 over, greater than 1 over 5. So we now know that the largest that 1 over x can be is 1/3, and we're going to use that fact right here, because this is really 1 over the absolute value of x. So we're going to now replace that. We're going to get the absolute value of x minus 4 over 4, and then in place of the 1 over x, we're going to put a 3, and then we'll multiply by 12. So we'll have absolute value of x minus 4 is less than 12 epsilon. So I'm going to go over to the next slide here and show you what we've done. So we've said that the difference between the function and the limit was less than epsilon whenever the absolute value of x minus 4 is less than 12 epsilon, but we have also assumed that the absolute value of x minus 4 was less than 1 at the very beginning. So we really want to take the minimum of these two. Our delta is the minimum of either 1 or 12 epsilon. So I think we talked about this in class. When you have some function, and here's your limit, we'll say as x goes to a, if you have some epsilon that you've chosen and you follow these over, we'll call that delta 1. We'll follow this one over and we'll call this one delta 2. Well, anything in here would work over here on the left, but if I was outside of the delta 2 range, I might not be okay on the left-hand side. So that is why these are really our delta 1 and our delta 2. We want to choose the smaller, because if I'm in this range on either side of A, then I will be within that epsilon of L. So I hope that helps. I will send this shortly.